Lesson 4.3. Solve x squared plus bx plus c equals 0 by factoring. Factoring is the opposite of FOILing, so it's unmultiplying. Undoes multiplication. When we multiplied x plus 2 times x plus 5, we got the x squared plus 7x plus 10. Factoring goes backwards. The x plus 2 and the x plus 5 are called binomials because there's two terms, two numbers. And the x squared plus 7x plus 10 is called a trinomial because there's three terms. So to factor a trinomial, we start by writing two sets of parentheses. And then we guess and check. You look at the first term and say, what times what makes that ax squared? And you put that in the first of each set of parentheses. Then you look at the last term and say, what times what makes c? And you put that in the last part of each parenthesis. And then you check by making sure the outers plus the inners equal the middle term, bx. For example, let's factor this. It's three terms, so we write two sets of parentheses. We look at our first term, x squared, and say, what times what makes x squared? Well, it's x times x. And then we look at the last term, the negative 18, and say, what times what makes negative 18? Well, how about negative 9 times 2? Now I made the 9 negative because my middle term needs to be negative. So let's check. The outers, x times 2, and the inners, negative 9 times x, does that equal negative 7? And you check by seeing if that is the same as the middle term, negative 3x. It's not, so it doesn't work. So let's try something else. X squared is still x times x, but what else times what else makes the negative 18? Well, how about 6 times 3? So maybe we could try a negative 6 and a positive 3. So we test the outers and the inners. The outers are 3x, inners are negative 6x. Add those together and we get negative 3x. Oh look, that's the same as the middle term up there. So, since it matches the middle term, that is the correct factoring. Let's try another. It's three terms, so start by two sets of parentheses. And then, what times what makes n squared? Be n times n. And then what times what makes 9? Well, how about 3 times 3? And I made them negatives, because negative times negative is positive, and I want the middle term to be negative. Check with the outers plus the inners. The outers are negative 3n. The inners are negative 3n. Add those together and we get negative 6n. But that doesn't match my middle term of negative 3n. So that's not the good factoring. So let's try again. N squared is still going to be n times n. But what else times what else makes 9? How about 1 times 9? So let's try negative 1 times negative 9. Test this with the outers and the inners. The outers are n times negative 1. Inners are negative 9 times n. Add those together and we get negative 10n, which is not negative 3n. So that doesn't work either. I can't think of anything else that multiplies together to make 9. So, since there's no other possibilities, this one's not factorable. Let's try another one. Put your parentheses. What times what makes r squared is r times r. What times what makes negative 63? Well, how about negative 9 and 7? Check. The outers are r times 7. The inners are negative 9 times r, so if I add those together, I get negative 2r. Well, that doesn't work. However, notice we wanted a positive 2r, but we got a negative 2r. We can fix that by just switching it around. So instead of negative 9, we'll use a positive 9. Instead of positive 7, we'll use negative 7. So when you get the correct number but the wrong sign, just switch the pluses and minuses, and it should work out. Outers are negative 7r, inners are 9r. Add those together, you get 2r, which is what we're looking for, so it works. There are some special factoring patterns, such as the difference of squares. A squared minus b squared equals a minus b times a plus b. Perfect squares, a squared, and I have the plus or minus. If we use the plus and minus here, if you use a plus here, you'd use a plus there. If you use a minus here, you use a minus there. The 2ab plus b squared. You can see how the formula works. So here we have x squared minus 9. Now we could factor this the way we were factoring everything else. We're putting two sets of parentheses. But if I look at this, I can see that it is a difference of squares. It'll be x squared minus 3 squared. So then our answer, which is a minus b times a plus b, be just x minus 3, x plus 3. Or maybe here's this one. Now this was a little harder to notice. It's a perfect square. 81 is 9 squared, and 18 is 2 times 9 times the w. So we see it's a perfect square, and we're using the minus. So in this case, the a is w, the b is 9, and we're using the minus. We could do this the longer way and just have our two sets of parentheses and say, oh, what times what makes w squared? What times what makes 81? And check outers give us negative 9w. Inners is another negative 9w, which gives us a negative 18w. Since they're the same, you'd write it as w minus 9 squared. Purpose of factoring is to be able to solve quadratic equations. The solutions to quadratic equations when it equals 0 are called zeros, because those are the values of x to make the equation equal 0. We use the zero product property, which is 0 times anything equals 0. So, if I have two things that multiply together, say a times b, and it equals 0, then I know either a is 0 or b is 0. Or possibly they're both 0. But I don't know which ones. So we'll have to check all of them. So what we're going to do is factor our quadratic equation. And that gives us two pieces that are multiplied together. And we take each of those and make them equal to 0. So here's our first one to solve. It equals 0, so now let's factor. So I said, what times what makes the x squared? X times x. What times what makes negative 42? Negative 7 and 6. And we check that with outers, 6x. Inners, negative 7x, 6 minus 7 gives me the negative 1x. Now it's the checking. It works. Now I take each of the factors and make it equal to 0, because if one of them is 0, 0 times whatever the other one is still 0. So I've taken the x minus 7 equals 0 and the x plus 6 equals 0. Solve each of those and you get x is 7 and x is negative 6. So which one's correct? They're both correct. You can check by plugging them in and you'll see that in fact they are both solutions. Let's try another one. Start by factoring. Say what times what is x squared? Probably x times x. And what times what is 16? Well, maybe we try negative 4 and negative 4. Check our outers and the inners. The outers, negative 4x. Inners, negative 4x, makes negative 8x, which is what we're looking for. So that worked. Now take each factor, make them equal to 0. Yes, I know they're the same factor. And solve them, you get x is 4. So our solution is 4. Take that, check it by plugging it back in. Sometimes we're going to need to find zeros. Zeros are the value of x when y equals 0. And they're sometimes called x-intercepts, or roots. So when you need to find the zeros, you make y equals 0, and you solve. So we need to find the zeros of this equation, and we're going to do it by writing an intercept form. Intercept form simply means factored. Remember, it was parentheses, x minus p, x minus q, it's just factored. So we need a factor. So you have to say, what times what is x squared? Probably x and x. What times what is negative 30? Maybe negative 10 and 3. And then we need to check. Now, let's check. Outers are 3x, inners are negative 7x, negative 10x, sorry. 3x and negative 10x give us negative 7x. Each factor equals 0, so you can see x is 10 and x is negative 3. So the zeros are 10 and negative 3. Which are the values of x? If you plug it in, y would be 0. And that's it for today. Enjoy working on the homework.